Now we're doing the review for section 1-3. And the first question says we've got a 100-pound cargo of delicate electronic equipment, and it is dropped by parachute from an altitude of 2,880 feet and lands 200 seconds later. So they want to know, A, find a linear model relating the altitude, A, in feet, and time, T, in the air, T in T seconds. Okay, so our ordered pair is going to have the form, the independent variable is always time, T and A. And let's come up with a couple of ordered pairs here. There must be two, and let's see. At time 0, we're at 200 or 2,880 feet, and at time 200, our altitude is 0 feet. We've hit the ground. So now let's find the slopes. So m equals 2,880, and we have a 0 down here, and then minus and minus, and a 0 here, and 200 there. So ultimately we have negative 2,880 over 200. And when we reduce, we get minus 1440 over 100. And if we move decimals over twice, in each case, we wind up with a slope of negative, or a rate of change of negative 14.4. And notice these are feet in the numerator and seconds in the denominator. So that's also the speed it's falling, feet per second. So now let's come up with that equation. So we've got the altitude minus, and we're going to use the point-slope form of the line. Well, I might as well use this point right here, 200 and 0. So A minus 0 equals, and the slope negative 1.4, excuse me, that should be 14.4, 14.4 times, and T minus 200. So A of T equals a negative 14.4 T, and a minus times a minus is a plus, and that's going to be 2,880. And there's our equation. And this was A, by the way, this was A. For B, they want to know how fast the cargo is moving when it lands. Well, it's falling at 14.4 feet per second. So we've taken care of A and B both. We're done.